Hey everyone, my name is Jeremy Lamb, and I'm the inventor of RoboBear and a RoboBear teacher. Today I'll be teaching you guys how to build your very own RoboBear. At the end of the tutorial, you will have your very own hugging or walking RoboBear. In the tutorial, you'll learn how to assemble the robot parts that we see in front of us here, circuits, hardware, and basics of how electronics and electricity works, and also you'll learn how to program your RoboBear to hug and walk. So let's get started. So here are all the different robot parts that'll come in your RoboBear kit. Let's step through them one by one. First, let's take a look at these. You should have two of these. These are called servos. The servos are what we're going to be using later to move the RoboBear. So we should have two of these. This is an Arduino Uno microcontroller. A microcontroller is the brain of a robot. So later when we do our programming, we're going to upload our programming to this Arduino Uno microcontroller. Our programming is going to live here, and this is going to tell the servos what to do, how to move. This is what's going to control our RoboBear. Here we have these two plastic pieces. You should have two of them, and they're different shapes. So let's take a look at this one first. This one looks like this. The rectangular pieces are longer on the vertical side. This is an acrylic frame. Now, acrylic is just a fancy name for plastic, and this is going to be our hugging frame. We're going to put the servos into here, and it's going to allow RoboBear to hug, and it's going to keep the servos in place. This second acrylic frame looks like this. It's longer. The rectangles are longer on the horizontal side, and a little bit shorter than the hugging frame. This is the walking frame, also made out of acrylic plastic. Both of these were actually laser cut from a big sheet of acrylic plastic and cut out with lasers. So this is our hugging frame. This is our walking frame. And here we have, we should see these two plastic pieces. These are RoboBear's arms. From here on out, we'll just call them the arms. These are actually made out of another type of plastic called polycarbonate. These are polycarbonate arms. And you should have two of them. This white thing up here that you see how this part is clear and this part is white. This white thing is actually a servo horn, which you will see a couple of them in the bags with the servos. This white thing is a servo horn, and what we've done is beforehand we've hot glued the servo horn to the polycarbonate plastic pieces to create this arm. Cool. So in the next one, you should see 4 wires, and it doesn't matter what color the wires are. All wires are the same regardless of what color they are. You should see 4 of these separate wires. They're all separate. They're not attached together. And we're going to be using these wires to connect the Arduino Uno microcontroller to the servos. These two things need to be connected somehow so that the Arduino microcontroller can control the servos, and the way we're going to do that is by using these wires later. There's another piece. This looks kind of like a Christmas tree. It's 3 wires, 1, 2, 3, attached at the top. This thing at the top, see this shiny metal-like material here? This is called solder. Solder is a type of metal that we use in electrical engineering to connect circuits together, to connect wires together. And the solder, this metal, conducts electricity. So later you'll find out exactly why we need this. This is a 9-volt battery holder attached to a barrel jack adapter. This part is for attaching the battery, and later on we're going to be attaching this 9-volt battery to the Arduino microcontroller to power the microcontroller so it can move the servos. And we're going to be using this 9-volt battery holder to connect the 9-volt battery later. And last but not least, of course, we have our teddy bear, which we are going to make move using the robot parts. Two things that we definitely do need. Or if you're doing this at home, make sure you have these parts as well. A screwdriver, and you can get these screwdrivers from the dollar store, from Walmart, from Amazon. This is a very standard precision screwdriver, and that just means it's small. It's a small screwdriver. You can kind of take a look here, and we're going to be using this to screw the servo horns onto the servos later. And here is a USB cable, and we're going to use this cable to connect the computer to the Arduino, so the programming can get stored onto the Arduino. Of you guys at home probably have this. If you have a printer at home, most printers use this kind of USB cable. So, or you can also get it on Amazon. Of course, I'll have links to where you can find this equipment as well. But if you're taking the class, the teacher should also have this. This is a bit of an optional piece of equipment, but it does make the class a little more fun. This is a multimeter, and we're going to be using this later on to measure the voltage of the battery. And you'll get to learn how to use this as well. So these are all of the parts that we're going to be using. So let's go ahead and get started with building. The first thing we're going to do is we're going to take out our servos, both of them. Let's go ahead and take our bags with the servos, and we'll just take the servo out. Now in the bag you'll find another little bag with screws. We're going to use that in a bit, but let's just take our servo out for now. Let's unwrap the wires from the servo. So here's our first servo, and here's our second servo. So we now have our two servos. Let's find our hugging frame. Remember, our hugging frame looks like this. So we'll take our hugging frame, and we can take one servo and see this wire here at the end of the servo. We'll take our hugging frame in one hand, and we'll take the wire in the other hand, and see this hole over here? We'll just pick one of the holes, and we'll take the wire and put it through the hole. So we'll take the wire and put it through the hole, and then we'll pull until the servo sits nicely on top of the frame. And a tip and trick is angle the servo down a little bit so you have this part already through the hole. So it kind of looks like that. And then what you can do is you can take your fingers and then kind of push this way, in this way, and down a little bit. And then there you go. And then the servo fits nicely inside the hole here. So we're going to do the same thing on the other side. Notice how the wire is facing out from this side. When we put the second servo in there, we want to make sure that the wire faces the same side. So with that in mind, I'm going to take the frame in one hand again, take the wire in my other hand, and then put the wire through the hole, just like we did last time. And then when I'm putting it in, make sure that the wires are facing the same way. Angle it down a little bit to make it a little bit easier to push in. Otherwise, it might get a little hard because the wires do get in the way. But if you do it like this, we can just push in this way, and then it'll fit right in. And now we have both servos inside the frame. The next thing we're going to do is we're going to take our two arms over here, and we'll take one arm first. We'll take one arm, and we'll put it on the servo here. And notice how on this arm, the white piece specifically, there's a larger hole and there's a smaller hole. Larger, smaller. So this is the top and this is the bottom. So top, bottom. And what we're going to do is we're going to take the arm and we're just going to snap it right on here. Give it a little push, and then it'll go straight on. And then now the arm will move around. Now what's very likely going to happen is when we put the arm on there, it's not going to be in the position that we would want it later. And the position that we want it to be in later is more like a rainbow, like a rainbow shape. or like this. So because this will help us create our hugging motion. So right now I notice that and one thing very important about servos can only move 180 degrees, meaning it can basically it can only move from left to right. It can't move all around in a full circle. It can only go from like here to here. And I would actually want to make this arm go a little further that way, so it points more like this. So more this way. So what I'm going to do is I'm going to move my arm all the way until I cannot move it. And I know I want to make it move, go that way a little bit more. So I'm going to move it as far as I can. I'm going to detach it. I'm going to take it off. So now it's off. And then I'm just going to put it where I want it to be. So this looks about right. So I want it to be over here. And what happens now is now my arm is moving more like a rainbow. So like this. Cool. And we're going to do the exact same thing with the other arm. Put it on. Move it all the way to one side. And we do want to make it look a little bit symmetrical. This is the farthest this will go. This is the farthest this will go. I do want to make this match this side. So I will remove it. I'll move it as far as it can go. Remove it. And I want to make it look more like this. And it doesn't have to be perfectly symmetrical, it just has to be close enough, because when we put in the teddy bear, it actually won't really matter. So more like this, and then so now this arm will kind of move like this in the rainbow shape. Now one thing to note, not all of these servo horns sizes are exactly the same, meaning some arms you'll find when you're trying to attach and reattach and move them around to test them out, they'll keep snapping off, and that's okay, because in just a second we're going to screw them on. But do your best to try to put them on and then move them all the way and have it look like this and be able to move like this. And once you have it on, we can keep this on and we can put it on the table now. And here we're going to find these bags again from where we got the two servos, and we'll take one of these bags. We'll take the bag inside with the screws, with the little screws. Now, it doesn't really matter what screw you pick. There are 3 screws. There's actually 2 big screws and 1 small screw. If you can kind of see there. I usually pick the smallest screw. The smallest screw in this bag is actually this little guy over here. So I'm gonna take the small screw. But again, if you don't have a small screw, or if you don't want to, the other screws actually work just as well. So I'm going to take this, and you guys see this hole over here? I'm going to take the screw, I'm going to put the screw on top of the hole. Just have it sit on top of the hole like that. And it'll move around a little bit and it might fall. If you lose your screw, you can actually just use any of the other screws. So I'm just going to have the screw sit on top here, and I'll take my screwdriver. And this is a plus screwdriver. You can actually also use a minus screwdriver as well. It just has to be around this size and it'll work. So, but in my case, I'm going to take this plus screwdriver and I'll take the screw and I will screw it clockwise to tighten. So righty tighty, lefty loosey. I want it to make the screw tighter, so I'm going to turn right clockwise. So now it's completely attached, so when I try to take it off, it doesn't take it off. So I'll just do the same thing with the other one. I'll take this bag, take the smallest screw, put on the hole, and take my screwdriver and screw. Yep, and there we have it. So now we have them securely fastened on the arms, and later if we find that we do want to move the arms, we can always unscrew it and reattach them. sometimes the arms will move positions, and if you find that your bear the arms are moving really weirdly, that might be the case. And what you can do at that point is you can take the screwdriver, unscrew it counterclockwise to unscrew to make it looser, and reattach them just like we did before. But for now, they're good. Now, moving forward, we are going to refer to this side with the wires as the front. So this is going to be the front. The side without the wires is going to be the back. And so I'll point it, where you guys, from your angle. So this is the front. This way is front. This way is front, meaning this is going to be our left arm, and this is going to be our right arm. These arms, say left arm, is going to correspond to the teddy bear's left arm here. So left arm here, left arm here. Right arm over here, right arm over here. Cool. We can now move on to the Arduino. So the Arduino will come in a little box like this, and all we have to do is we can open the box. So we'll open the box. Don't worry about breaking the box. You can actually break the box now a little bit. We'll be using the box later, so don't break it off completely. But don't worry if it breaks a little bit. That's not a problem. So we'll open up the box, and you'll find a couple things inside, and these things might change over time, like a little booklet, a couple of stickers. You can keep that for yourself if you want to, but we will not be using it for the class, so we can just set that aside here. And my box also came with these little white things. These are actually, normally they're used to, people stick these they take these little white pieces off and they stick them and give their Arduinos like little legs to stand on so you can set it down. Because the back is a little bit spiky. So, but we're actually not going to be using this. We don't want to stick these onto the back of our Arduino. And you'll find a little sticker over here. It doesn't really matter. You can take it off or you can keep it on. I'll keep mine on. And so this is our Arduino Uno microcontroller. I did mention that in the back it's a little spiky. This again is solder, and solder, as we mentioned before, is metal that engineers melt on electronics to connect circuits, to connect points together. So the spiky things is solder. It is a little spiky, so be a little careful. Don't poke yourself too hard with that. Now we're going to move on to wire up the Arduino Uno with the servos. Notice how there are holes on the Arduino Uno microcontroller on the left and on the right. These holes, these black holes over here, we're going to refer to them as pins. So these holes are called pins. And also notice there are the same kind of holes on the servos here and here. There are 3 of them here and 3 of them here if you look closely. And these are also pins. So we have holes, we have pins on the servos and we have pins on the Arduino. And what we're going to do next is we're going to take our wires from before, and take one side of the wire, connect them to a pin on the Arduino, and then connect the other side of the wire to the pin on the servo. And I'll show you exactly how we're going to do that. The first thing I'm going to do is I'm going to draw an Arduino. So this square in the middle here will represent the Arduino. I'll label that. I'll go ahead and draw the side over here. And these 2 columns are going to be our pins, where our pins are. So the left and the right side. I'll go ahead and also draw the 2 servos. So we have our left servo and we have our right servo. I'll go ahead and label that left servo and right servo. This little this little barrel jack cylinder port over here, and this is for the USB, the silver part. So the side with these parts is going to be the top. So this is the top of the Arduino. Just so now we know this is the left side, this is the right side, left side, right side. Let's take a look at our Arduino Uno microcontroller, and can everyone please find a pin called 5V. So 5V is right over here on the left side, and so I'm going to just go ahead and draw that on 5V. Next, can you help me find a GND? And there's actually 3 GND pins. So the 3 GND pins are, there's 2 over here. It's actually a little easier if you flip it to the side. There's 1 GND pin here, the second GND pin here, and there's also one on the right side over here. Here it says GND right there. So these are the 3 GND pins. So I'll go ahead and draw those as well. GND, GND. And one more over here, GND. And GND is actually short for ground. So we'll go over that in a bit as well. And the last 2 pins that we're going to be using are pins 9 and 10. Pins 9 and 10 are on the right side, right over here, pin 9 and pin 10. 9 and 10. Also, it might be a little easier to flip it over on the other side. 9 is over here, 10 is over here. Cool, so these are all the pins that we're going to be using to hook up our Arduino microcontroller to our servos. And you'll also notice on the servos themselves, let's take a look at one of our servos, bring that back in. There are 3 wires, brown, red, and yellow. And you'll notice the wires all go to a single pin. So this is actually for brown, this middle one is for red, and this third one is for yellow, in the same order. So I'll go ahead and draw those on the diagram here as well. So there's three wires here, brown, red, and yellow. Again over here, 3 wires, brown, red, and yellow. So what we're going to do is we're going to start connecting the Arduino over to the servos. But before we do that, I want to go over some basics about how electricity works. What's going to happen is we have a battery that attaches to the Arduino up here, our 9-volt battery here, and it's going to connect to our Arduino and give electricity to the Arduino. The electricity, we're going to use electricity that the Arduino got from the 9-volt. Electricity is going to go from the Arduino to the servos. And the way servos work is when they get electricity, they start to move. So electricity is going to go from the battery to the Arduino, Arduino to the servo, move the servo, basically move the teddy bear's arms, and then the electricity is going to come back out into the Arduino and back to the battery. So exactly how it works is electricity works a lot like a water slide. So imagine like a little water slide. You know how at the top of the water slide you have water, and then water flows down because of gravity to the ground or at the bottom of the water slide. And then electricity works the same way. So we have a high voltage. So instead of in a water slide you have high ground and low ground. In electricity you have high voltage. In our case it's 5V or 5 volts of electricity, and at the bottom you have close to 0 volts, 0V of electricity. And 0 volts is also called ground, GND. So and imagine now, I guess instead of a water slide, it's more like a waterfall. In some waterfalls, there are these water mills that kind of look like this, and then the water flows down through the water mill, and they turn the watermill. They cause the watermill to move because water is flowing through here, and then it moves the watermill, and then it flows down to the ground. Same thing happens in electricity. Electricity, 5 volts of electricity is going to flow down, and instead of a watermill, it's our servos. So the 5 volts of electricity is going to flow down, turn the servos, and then move the teddy bear's arms, and then flow down to ground, to GND. So it's going to go from 5 volts through the servos to GND. So here's exactly how we are going to hook up the wires. 5V is going to have to go power the left servo and the right servo. What typically happens is it would take a wire, and you don't have to don't follow along for this part yet. I'm just kind of showing you guys. So don't do this part yet. You normally take one wire and put it in the 5V pin. So take the one wire and I would put it in the 5V pin, and then I would attach this 5V pin to a servo. But I think we have a problem here. We have how many 5V pins do we have? We have one. But we have 2 servos that both need 5V. This can only go to one servo because we only have one wire. And it's not really possible to take a second wire and plug it into the same 5V. See, it doesn't fit. I can't put it in the same 5V. So my question to you is, how can we give both the left and the right servo 5V when we only have one 5V pin? What we're going to do is, remember these wires? So these are 3 wires attached together with solder. And solder, as you remember, conducts electricity. So what if we did this? So we have this thing over here to represent our 3 wires. So our 3 wires are all connected together. Can anybody take a guess at how we can use this to give both the left servo and the right servo 5 volts of electricity? The way we're going to do it is we're going to take one of the wires, and it doesn't really matter which wire. All the wires are the same. So we can just pick one wire, and then we're going to take one wire and attach it to 5V right here. And now we have 2 wires left. And what happens in electricity is, so I'll go ahead and just take one of these wires. In the drawing, I'll pick the middle wire just because it's easier to draw. But once we connect one of these wires to the 5V, 5 volts of electricity is going to go up this wire, and it's going to be distributed to the other 2 wires. Kind of like in a river, and you have a fork in the river. So you have one river, and then suddenly it splits into 2, a left and a right side. Water goes from the one river, and it splits, and water will continue to go and get split to the left and the right river. Same thing happens with electricity. Electricity will go up here, and it will get sent out here and out here. So this way, we have 5 volts of electricity going to our left servo and our right servo. And the way we're going to hook it up to the servos is the red is going to go to 5V. So the red goes to 5V, just like that. So that's how it looks in the diagram. In real life, it looks like this. So we can take our servos, we take this. Now remember, the red wire is the one in the middle, so we're going to take the hole that's in the middle. That corresponds to red. We're going to take one of our wires, doesn't matter which one, we'll just pick one, and then we'll poke it into the middle hole for red. Do the same thing with the other side. Like that. So after this, your circuit will look like this. Cool. So the next part we're going to do is we have 5V now. The next thing we need to do is hook up ground, GND. Brown goes to ground. Now because we have 3 GND pins and only 2 browns, we have enough GND pins, so we don't need to do this thing again. We can actually just take one of our normal wires that look like this, We actually need 2 of them. We'll take one of them and hook them up to the brown of the left servo, and the other one hook it up to the brown of the right servo. It helps you remember because it kind of rhymes as well. Brown goes to ground, and it doesn't really matter which ground pin it goes to. All grounds are the same. All grounds are 0 volts approximately. So we're going to take this ground over here and connect it to brown. I like to use this ground on the right just because it's closer. So we can do the same thing now with the actual circuit. So I'll go ahead and put the circuit back on. We'll take one of these separate wires. We'll plug, and start with the left servo. Again, the side with the wires is the front, so this is left, this is right. It doesn't matter which side, but we can just take a wire, plug it into brown, and then plug that into a ground pin. And there we go. That's one of the grounds. And then same thing on the other side. Take brown and connect it to ground. I'll use this one this time. Oops. And at this point, go ahead and just double check wires are in the right place. 5V, make sure it's actually 5V. Sometimes when you look at it from the top, it's a little hard to see which pin is which. Sometimes it might help if you flip it on the side. If the side of your Arduino has these, it really helps. This is 5V connected to this little 3 wires connected together, and these all go to the middle pin, the red one, and then brown is going to ground. The last thing we're going to do is we're going to connect 9 and 10 to the yellows of the left and right servos. And at this point, it actually matters whether we connect to the left or the right servo. So the order does matter in this case. But before I mentioned that in order for electricity to flow through the left and right servos, we need 5 volts and ground to create that water slide effect. But the 5 volts and ground only allow the servos to move, to physically move, to power the servos. Exactly how they move and where they move, that is determined by pins 9 and 10 and the yellows over here. And what I mean by that is the servos actually move in degrees. So here, this is 0 degrees, if you guys are familiar with degrees. This is 90 degrees. This is 180 degrees. You know, over here is 60 degrees, over here is 30 degrees, somewhere over here is 120 degrees. So this number, you know, this degrees number, 0, 90, 180, these are actually numbers that we send from the Arduino in our programming that we do on the computer later to the servos, and the servos get this number, whether it's 0 degrees or 90 or whatever, and that number goes through pins 9 or 10 and goes through the yellow wire. So how we're going to hook them up is, don't worry if it doesn't make too much sense right now, it will actually make a lot more sense when we get to the programming. So what we're going to do now is, the picture will start to get a little bit messy, but bear with me. 9 will go to the left yellow. So pin 9 will take a wire and it'll go to the yellow pin, yellow wire of the left servo. 9 goes to left yellow, and 10 will go to right yellow. And at the end of the day, you'll have something that looks like this. And I also have a printed diagram that's a little bit cleaner that I'll show you guys, but I wanted to draw it out step by step for you guys as we're going through this. So I'll go ahead and wire the yellow ones up now. So take one wire, connect it to yellow, because the side with the wires is our front. This is going to be left. Left servo yellow goes to 9, and this is our right servo. Right servo yellow. Right servo yellow goes to 10. Now, a couple problems that we've seen before. Sometimes when we're trying to do this, our wires might get bent a little bit. It might get a little bit hard to plug the wires in, or if the wire is too short, the wires it could cause the wires to keep falling out. We should have some spare wires. The other problem that I've seen is you don't need to push the wires in all the way in. Once it stops moving, that means it's all the way in. You might have a little piece of silver part of the wire sticking out. That's okay. So what we're actually going to do later is we're going to be putting this inside a box, and just to make things a little bit simpler, we actually do want the side with the wires here. Notice how the wires are coming out this way. We actually want that to be facing up this way because we're going to be hooking up cables on this side. We all want everything to point up this way. So what I'm going to do, the wires are all bendable. I'm actually going to take this silver part because I don't want the silver part to touch the silver part. Because there's electricity going through here, and this is metal, and metal conducts electricity. If this ends up touching later when this is powered on, the electricity will actually jump over onto here and go to the wrong place. It might cause your teddy bear to restart. So I'm going to go ahead and take this and move this down this way, so it's facing this way. I'll take these wires and make them point up this way along with the other cables. If you do this and your wires fall out, go ahead and you can go ahead and rewire them according to our diagram over here. So 5V goes to red, brown goes to ground, left yellow goes to 9, right yellow goes to 10. Okay, and at the end of the day, you will have this. It'll look like this. We will go ahead and test it out. On your computer, you should already have the Arduino software downloaded and installed. If not, don't worry, I will also share installation instructions on how to download and install the Arduino software. It is free. Now that we have our circuit all wired up, and it'll look like this, go ahead and open up the RoboBear folder, and I'll have a link to where you can find the RoboBear code and the RoboBear folder. I have mine on the desktop. Open up the RoboBear folder, open up RoboBear Hug, and then a RoboBear Hug folder. And in the RoboBear Hug folder, they'll find robobearhug.ino. Go ahead and open that up. And you can do this on a Mac or a PC. Arduino will open up, and it'll typically open up two windows. One is blank. We can actually just X out of the blank one, and then maximize the one with actual code in it. This is RoboBear Hug, and it'll say at the top of the file. Go ahead and take this USB cable, and notice how there's two sides over here. Usually the side with the holes that you see that go through, not the side that's filled up, but the side with the holes points up. That's how it is on my computer, so that's how I'm going to plug it in. If you try to plug it in and it doesn't work, you can always just try the other side. So I'm going to plug that in. So I'm going to plug the USB into my computer. I'm going to take the other side that kind of looks like a house over here, and I'm going to plug that in. Take my Arduino and plug that in to here, the silver part, the silver hole that you see over here. I'm going to take this, I'm going to plug it in, and just to take one more look, the side that looks like the top of the house, that faces up. So I'm going to make sure that faces up as well. And try to plug that in, get that connected. And once you get that connected, you'll notice that the lights start to turn on. So if you connected it up correctly, the lights should turn on. Go ahead and see this button. A button that looks like a right arrow icon, and once you hover over it, it'll say upload on the right over here. So it'll say upload. Go ahead and just click that, and then you might see some error messages. On my computer, I need to go down and select the one that says USB. On a lot of other people's computer, what they actually have to do is actually I'll show you guys. They have to go to Tools, serial port, and you won't see what I see. You'll see something like COM3 or COM5. Go ahead and find the COM whatever that says Arduino Uno next to it. So go ahead, once you do that, once you see that, so Tools, serial port, and then pick, if you're on a PC, click the one that says COM3 or COM5, and then it says Arduino Uno next to it. And click that. Once you've clicked that, and if you're on a Mac, go to Tools, Serial Port, like I am, and pick the one that says USB. I usually just pick the first one, and then that should fix your upload problem. So pick the right USB one, and then click OK. And then on the bottom, on the left, it'll say uploading ... and it'll just say done uploading, and then it should give you a bar. Now, what I'm observing, so it just uploaded to my Arduino. It looks like there is a problem with somewhere in my circuit. What we should see in this test program is the left and the right arms should be moving. Now, only the right arm is moving, but the right arm is moving correctly. So that's a signal for me to take a look at what's wrong with my circuit. So we'll go ahead and do that. But before we take a look at what's going on, what I'm going to do is I'm going to go ahead and just go to my computer here. You can remove and go ahead and disconnect the Arduino from the computer. What the computer is actually doing is it's giving power to the Arduino, just like how a battery would give electricity. The computer is giving electricity to the Arduino. That's why it's able to move. We don't want the Arduino to be powered when we go and take a look at what's wrong with the circuit. So let's go ahead and take a look at what's going on with the circuit. So as we noticed before, the right arm moved, but the left arm did not. So what I want to do is, because the right arm's working fine, I don't really need to take a look at the right arm. I'm going to take a look at the left arm. So these are the wires that connect up the left arm. And if yours is working, you can kind of skip through this. But I'm going to make sure that red is connected to 5V, so it's connected over here. And this, yes, this is going to 5V, so over here, check. And again, if there was a big problem with 5V, the right arm wouldn't move either. So as long as this over here, 5V is connected to my left red, it looks good right now. So the next one is brown, needs to go to ground, so I'll take a look at my left. This is my left, again, still my left servo. Left brown is connected to ground, so that's correct as well. So there's one more wire left, and that's the yellow. So I'm going to take a look at my yellow, of my left servo. Yellow left, you guys remember, needs to go to 9. And oh, okay, well you look at that. So see this right here? It looks like my left yellow detached. That's why you see all the silver out here. It should actually be inside the pin. So what I'm going to do is I'm going to go and plug that back in. So without this plugged in, the left servo isn't going to get that number that it needs to move to the right angle, the correct angle, like 0 degrees, 9 degrees, 180 degrees, what we talked about before. If any of the wires are not plugged in, that particular servo will not work. If the 5V and the ground are not plugged in, it will not get power. If the 9 or 10 are not plugged in, it will not get the number it needs to move to the right spot. So let's go ahead and try that one more time. Now, we don't need to upload the program every single time. The program is already saved and living on this Arduino, so all we need to do is power it. An easy way to power it is to just plug it back to the computer. So we can take this. If you're using a laptop, I recommend plugging your laptop into power. I don't have mine connected to power. It's not a big deal, but I recommend plugging your laptop to power. So because the Arduino is taking power from your laptop, to prevent your laptop from running out of battery, I recommend plugging your laptop. So let's go ahead and plug the Arduino back inside the laptop, power it, and oh look, so now both of the arms are moving. And you can actually tweak the arms to move however you want. If you want them to be more symmetrical, I recommend we tweak the numbers. We can actually change the numbers in the code, but I recommend we do that after we put it inside the bear, because at the end of the day, they're going to be moving inside the bear. We want them to make it look best inside the bear. So, but the purpose of this exercise was to test that both the arms move, both the arms are moving, so success, we are okay to move on. If your arms are still not moving, to take a look at your circuits. That's very likely where the problem is a wire is misplaced. A couple things that I've seen, I've swapped pins 9 and 10 before, And when you swap pins 9 and 10, normally the hugging program is programmed to hug like this, right? If you swap pins 9 and 10, they're actually gonna do this more, like a much more crisscross type of hug, because it thinks that the left servo is the right servo, and it thinks that the right servo is the left servo. It's got it backwards, basically, if you swap the 9 and 10 wires over here. Another thing that I've seen is that we wire the ground and the 5Vs. In that case, it will not move. Something that we definitely don't want to do is plug this 5V over here and then have another 5V wire connected to ground. Now, what actually ends up happening is when we connect 5V directly to ground without a servo in between, that's called a short circuit. And what ends up happening is it could possibly burn out the electronics. And when I say burn, I don't mean a fire. It'll just it might break the electronics. Now, the Arduino is smart enough to protect itself against that. So what you'll probably very likely see if that does happen, worst case scenario, is the lights will keep flashing, meaning it'll keep resetting. The Arduino is constantly detecting that you have a short circuit, and it's keep trying to reset and redetect until the problem gets fixed, until you fix the problem. Those are things to look out for. But once everybody's works, we can go ahead and start taking a look at the programming. Once you do have Arduino installed, we can go ahead and open it up. If you have a PC, I think it will create a shortcut menu with the Arduino logo on it. Go ahead and double click that. On my Mac, Arduino is right there, so I'll go ahead and open Arduino. So when you open up Arduino, it should look a little like this, a blank file, or I think recently the new files come with a couple comments. Either way, it's a new file. What we're going to do is, it might make it easier if we full screen it. So full screen it on your Mac or PC, and then once you're full screen, go ahead and go to File, go to Examples. And for this part, sometimes it can get a little harder if you're using a mouse. Go ahead and move your mouse horizontally to the right across examples to try to get over here. And once you get over here, move down and find servo under where S is, servo. And then again, move your mouse across to the right, over to the right. Now, if for some reason you come over here or you get over here, the window might kind of get lost a little bit. So we want to go to examples, servo, and then once you get to servo, you want to pick sweep. So File, Examples, Servo, Sweep. Go ahead and click on that. And then now we will open, it opens up a sweep folder. We can go ahead and maximize the screen now. Once we have the sweep program opened, I'm actually using a bit of an older version of the example program, so there might be slight differences, but not huge differences. After we've opened up sweep, let's go ahead and look up at these little icons up here. So go ahead and find the the icon that has a check mark, the check mark icon, and hover your mouse cursor over the check mark, and you'll see on the right over here it'll say verify. Everyone, let's go ahead and click the check mark button. And then you'll notice here, down here, it says compiling sketch ... and you'll see this bar, progress bar, go across. And when it's done, this bar will be green, and it'll say done compiling. When we clicked the check mark button, what the computer did is it read through all of our code and looked for spelling mistakes and other mistakes in the code. And if it turns out that this is green, it means there are no mistakes in the code, and there shouldn't be any mistakes in the code because this is an example program, as long as we haven't typed anything in it yet. So let me show you an example of an error. So notice how on some of these lines you see these symbols. These are semicolons. And let's go ahead and just pick one of these lines. A semicolon is you know how in sentences we end every sentence with a period. In programming, we end a lot of our lines with semicolons. It's kind of like the punctuation for coding. And if we are missing a semicolon, for example, if I take this semicolon and I delete it, then we're now missing a semicolon, and that's actually an error. So what we can do is we can go ahead and click this check mark, verify, click it, and now we see that we don't get green anymore, we get orange, which means we hit an error. And let's go ahead and read what the error says. It says expected initializer before int. So the computer will do its best to try to tell you where the error is, but it doesn't really know exactly what the error is, and it doesn't really know exactly where it is, but it can kind of give you a general position. So here it actually highlighted around where it thinks the error is, and if we remember, we deleted the semicolon over here, so actually right up here we got the error because it was missing the semicolon. So if we go ahead and put that semicolon right back over there, and on the keyboard the semicolon is right next to, it's on the left of the enter key or the return key. So we put the semicolon back over there, and then we can click the check mark again, and then now we get green again. We get no errors, done compiling. So the computer caught the mistake. It found that we were missing a semicolon, and then after we added the semicolon back, we got green. We got no errors. For this next part, what we're going to do is we're going to go ahead and hook up the computer to the Arduino microcontroller. So we're going to go ahead and take this USB cable, go ahead and plug that in on this side, and then we're going to go ahead and take the Arduino, take the other side of the USB cable, plug it in just like we did before, and what's going to happen after we plug it in is it's going to start moving because we still have that the program from before we had in there, and we haven't changed anything. So once we have it plugged in, we'll go ahead and press upload. So we want to upload our sweep program to our Arduino. So now we have a new program on the Arduino, and that's the sweep program here. So this is what the sweep program is doing, the sweep program on our computer. So can somebody tell me what changed? Only the left servo is moving right now, and it's moving all the way from right to all the way to the left, all the way to the right. So this is important, and we'll understand why this is happening in just a bit as we step through the code. We can go ahead and unplug the Arduino from the computer now so it stops running. The first thing we'll see is a bunch of these gray words, these gray sentences. And these are called comments. They're basically notes that the programmer took to remind themselves of things. The computer doesn't read this. This isn't actually code that the computer reads. And a comment is marked or denoted by these / symbols. And whenever you see gray words, that means it's a comment, and it's not really part of the code. So the real first line we have is this line. So this first line says pound include servo.h. Now if we kind of scroll up and down the file, we'll notice that there really isn't a lot of code in the file, but it's actually, this program is actually still doing a lot. The reason why there isn't that much code in this file is because there's actually more code in this file called servo.h. So servo.h is the name of a file living somewhere else on your computer. We're going to be using code from servo.h to control our servos. So that's why we need to include all the code from this servo.h file. So what this line is doing is it's including all the code that tells us, how servos move and everything into this file so we can use it. Don't worry too much if this doesn't make too much sense. It's not too important. So moving on to the next line, servo my servo. So what this does is we need this program, as you saw before when we uploaded it, was moving a servo. And so in our program, we need a way to control the servo. And in order to control the servo, we need to give it a name. We need to give our servo a name. So in this case, we are calling that servo my servo. So this is our servo's name. We're going to be using this my servo later to control the actual servo that we move. And this orange text over here, servo, basically tells us and tells the computer what this thing, what this my servo thing is. And what this my servo thing is a servo. So my servo is a servo, and it can do servo stuff. And servo stuff, the things the servo can do, are all defined here in this servo.h file. There's a bunch of information that tells us what servo stuff servos can do, and it's all included in here. And we don't need all that code here because we're including all of that here. So on this line, we are creating a servo called myServo. So the next line says int pos equals 0. So let me break that down for you. Int is actually short for integer. Does anybody know what an integer is? An integer is a number that can be positive or negative, and it's like a whole number. So it's not a decimal number. So a decimal number is a number like 0.5 or 1.3 or something like that, or negative 2.5 or something like that. An integer, however, is a number like 1 or 5 or 12 or 50 or 100. And it can also be a negative number like negative 2, negative 15, any negative number that's not a decimal. And it can also be 0. Here we are creating a variable called pos, and pos is actually short for position, as they do explain in the comments. And we'll be using this to keep track of the position that our servos move to. And here we are setting it equal to 0. So in the next part of the code, we have setup. So in Arduino, we have usually the initialization part where we set up all our variables, declare all our variables, and then we have the setup and loop. And so let's take a look at our setup. Here it says void setup. So this line says myServo.attach 9. Can anybody take a guess at what this line does? If we take a look at the orange word here, attach, attaching is one of those servo things that servos can do. And it's attaching to something. Can anybody take a guess at what this 9 means? Let me ask you this. Everybody take their USB cable there and connect it up to the Arduino here, and take the USB cable and plug it into your computer. Plug it into the computer. So if you remember, the Arduino still has the sweep program. Which arm is moving right now? The left or the right? And let me ask one more follow-up question. Back when we were plugging in the yellows, the yellow wires to the numbers on this side, which pin was the left servo yellow attached to? The left servo, we'll take a look at the wires here, yellow here, and it is attached to pin 9. So what this line of code is doing is it's taking the servo variable, the servo object that we have, and and we're going to be using this myServo thing later to control the servo. But right now in the setup, it's attaching myServo to pin 9. To pin 9 on the Arduino. So it's basically mapping myServo to pin 9 on the actual. Now let's do an experiment. What would happen if we changed 9 to 10? Anybody to take a guess at what would happen? Let's go ahead and try it. So with the Arduino plugged in, go ahead and go to upload and click upload. So let's see, it's uploading and done uploading. What changed? The left arm is no longer moving, but now the right arm is moving. Can anybody explain why? We changed the number 9 to 10 here, and the left arm stopped moving and the right arm started moving. That's because now we are attaching the servo that we're moving to pin 10. And which servo's yellow wire is attached to pin 10? Let's see, pin 10. That's this wire over here that goes up to the yellow of this servo. Let's trace it back. It would be this servo, the right servo. So, does that make sense? So the right servo is moving because now we're attaching our servo to pin 10. So what would happen if we change this back to 9 and click upload? So when we change 10 back to 9, the left servo moves because the left servo yellow is attached to pin 9. I'm going to draw a circle. And in it, I will draw the servo that's moving right now. And are you guys familiar with degrees and angles? So can anybody tell me what, if this is 0 degrees, what angle is this one? This one would be 90 degrees. And can anybody tell me what this angle would be? This one is 180. Cool. So, if we take a look at our code, in the first part, we have for position equals 0. So what this is saying is I'm going to set pus equal to 0. So from now on, pus is going to be equal to 0 whenever you see pus. And then I'm going to check, is position less than 180? Well, position is 0 right now. Is 0 less than 180? Yes. 0 is less than 180. So plus equals 1. So what this does is, this is the same as saying, I want to add 1 to position. So position is 0. What's 0 plus 1? 1. So from now on, position is going to be equal to 1. So now we read the next line, my servo.right position. So we see another word here, right. Right is another thing that servos can do. Servos can write a number to the servo. So we're writing pos or position. What is position again? Remember, it started off as 0. We added 1 to 0, so position became 1. So by the time we get here, position is 1. So we're writing 1 to my servo. Is the servo will now move from 0 to 1. And what that looks like is the servo will move, this is 0, from 0 to 1. From 0 to 1. Let's keep going. The servo has moved to 1 degrees, and now we go to delay 15. So what this does is it tells the computer to wait, or it tells the Arduino to wait 15 milliseconds. Does anybody know how big a millisecond is? A millisecond is a very, very, very small second. There are 1,000 milliseconds in 1 second. So here we're waiting 15 milliseconds, a very short amount of time. And then that's all this does. And then we go down to here, and because this is a for loop, and loops go around, in a loop, goes around and repeats, when we get to this end curly brace, we actually go back up to the beginning, back up to the for loop. So because this is not the first time we're going through this for loop. We skip this part, and we skip directly to here, to this check. So does anybody remember what position is equal to right now? Position is still 1. So is 1 less than 180? Yes. So we move on. What's 1 plus 1? 2. So now position is equal to 2. MyServo.write. What number do we write? We write 2 because position is now 2. So what happens now is we move from 1 to 2. From 1 to 2. And basically, what ends up happening is we keep going all the way around. And I'll show you what happens in the code when we get towards the end. Say we're at 179. 179 degrees. Is 179 less than 180? Yes. So we move on to this part. What's 179 plus 1? 180. So now position is equal to 180. MyServo.write 180. We move from 179 to 180. 179 to 180. And now, what's position? Position is equal to 180. What is 180 less than 180? No. 180 is equal to 180. It is not less than 180 is not less than 180. So we skip everything and we skip all the way down to here and we move on to the next for loop. So now position is equal to 180. We set position equal to 180. What's position again? It's 180. Is 180 greater than or equal to 1? Yes. So we go to here, position minus equals 1. What this does is we take whatever position is and we subtract 1 from it. What's 180 minus 1? 179. So basically what happens is we go from 180 back up to 179, 178, all the way around. So now let's say we are back at 1. Is 1 greater than or equal to 1? 1 is greater than or equal to 1. So this is true. We move on to here. What's 1 minus 1? 0. So position is equal to 0. MyServo.write 0. We go down to here. We wait 15 milliseconds. We go back up. Is 0 greater than or equal to 1? No. So we skip this and we skip everything and we come all the way down to this end curly brace. And here, we're now here at the end curly brace. And then we come down to here. There's no more code. If we scroll down, there's no more code down in this file. And the computer is, the Arduino is at this last line of code. What do you think happens at that last end curly brace? And at this point, you don't have to do this. I'll actually just take my USB, plug it back in, and I'll run the servo. So basically what happened is we started here in the first for loop. We went from 0 to 180, what we see now. And then the second for loop, we went from 180 back to 0. But what's happening? What do we see? We go from 0 to 180, 180 back to 0, and then we hit the end of the code. Well, what's happening? Well, at the last curly brace, we actually go, in the code, we actually go all the way back up to here, to void loop. And that's why it's called a loop, because we start, we run all the code, we get down to the end, and we go all the way back up, and we do it again. We repeat. That's why it's called a loop. So what's happening is we're going up. We're going from 0 to 180 here, and then 180 back to 0, and then back up 0 to 180, 180 to 0, 0 to 180, 180 to 0. And that's basically it. And that's all of the example code. Now that we're done looking through the code, I want to present you guys with some engineering challenges. For the first challenge, notice how the servo is moving from 0 to 180 degrees. Instead of moving it from 0 to 180 degrees, can we program it so that it moves from 0 to 90 degrees? So instead of going to 180, we want it to go to 90. Can you guys figure out how to do that? Let's take a look at the code. We want to change how the servo moves. The code that tells us how the servo moves is down here somewhere, because this part just declares what the variables are equal to. This part sets which servo we're going to move, and this part is the actual part that actually moves the servo. So let's look somewhere in here. So our goal is to change it from going to 180 to go to 90 instead. So we don't want 180 anymore, we want 90. So here, I spot a 180 here. What would happen if we changed this 180 to a 90? So if we remember, the first for loop tells the servo to go from 0 to 180. So instead of going from 0 to 180, I suspect changing this 180 to 90 will make it go from 0 to 90. Let's go ahead and test it out. Upload. And always feel free to test out different pieces of code. If the code doesn't work, when you upload it, during the compile phase, the spar will turn orange, and you'll know when there's an error. If you have hit an error, all you can do is just do Control Z on your keyboard, or if you have a Mac, Command Z to undo, or just go to Edit and Undo. So let's go ahead and upload this with 90 instead of 180. Select my USB. Let's see what happens. Oh. So something's different. What I wanted to do on the left arm is I wanted to go from 0 to 90 and then 90 back to 0. But something's certainly different about this. I wonder can anybody figure out what's happening right now? Can anybody figure out what's going on? Well, it looks like it's going from 0 to 90, 180 to 0. 0 to 90, jump to 180, back to 0. So, it looks like it's going from 0 to 90 correctly, but it's still jumping to 180 and going back to 0. So how do we solve that problem so that we can go just from 0 to 90 and 90 back to 0 and not have the 90 to 180 jump? The first part of the for loop took us from 0 to 180 originally, and the second for loop took us from 180 back to 0. So what's happening now is we're going from 0 to 90 in the first for loop, but in the second for loop, we're still going from 180 back to 0. So we're doing exactly this, 0 to 90 in the first for loop, jump over to 180, 180 back to 0 in the second for loop. That's what's going on. So how do we make it so that we go from 0 to 90 and then 90 back to 0? Well, if these numbers mean we go from 0 to 90, then these numbers must mean we go from these numbers must mean we go from 180 back to 0. This actually means goes back to 0. So if we want to go from 90 back to 0, what if we tried this? If we change the 180 over here to 90. Let's go ahead and give it a try. Upload. Let's see what happens. 0 to 90, 90 back to 0. And there we go. And once you're done testing this out, you can feel free to change the 90s back to 180. It doesn't really matter, your preference. The second engineering challenge I want to give you is let's change the delays. Change the delay to any number you want and upload and see what happens. So I have 15 right now. So let's say I type an extra 0 in there and make that 150 instead of 15. Let's press upload and see what happens. What changed? The arm is going a lot slower from 0 to 90. But it still moves at the same normal speed from 90 to 0. Can anybody figure out why? That's because here we are doing a delay. We're waiting 150 milliseconds before we run each line of code. The longer we wait, the longer it takes for the arm to go from 0 to 90. So basically we're saying write 0 to the servo, wait 150 milliseconds, write 1 degrees, wait 150 milliseconds, write 2 degrees, wait 150 milliseconds, instead of the very small, short 15 milliseconds. Now, here's my question to you. Why is it moving slow from 0 to 90 and faster from 90 to 0? What if what we want to do is have it be slow from 0 to 90 and 90 to 0? So slow, one speed all the way through. Well, we would have to go down to the second delay and make that the same as what we have up here. This part moves, the first 4 moves from here to here. We change the delay here. The second 4 moves the arm from here to here. Well, we'll have to change the delay here as well to match the delay up here. Let's go ahead and upload and see what happens. So it's going slowly from 0 to 90. Very slow. And it's going slow back from 90 to 0, same speed. Now, here's the final engineering challenge. Make the arm move fast. If we originally started off with 15 milliseconds, when we changed it into 150 milliseconds, which is larger than 15, it got slower. So how do we make it go faster? Well, let's try picking a number that's smaller than 15. I want to change both of them because I want to change both, move both ways, same speed, both ways. I'm going to change it to 5, which is less than 15. Let's go ahead and hit upload and see what happens. And now it's moving faster because now between each line of code, we're waiting only 5 milliseconds, which is very, very, very small. Now, you can also do something fun, like what would happen if we did 0? Let's click upload and see what happens. So what's going on here? We're not even able to make it from 0 to 90. Well, what's happening is we're telling the servo to go from 0 to 90 and 90 back to 0 in 0 milliseconds, in no time. We are literally giving the servo no time to move from 0 to 90 and no time to move from 90 back to 0, which is physically impossible. So it's doing its best, but it's actually just shaking between a few degrees. Now, this is a lot of fun to look at, but I would recommend not running this for too long because we are moving the servos at extremely high speed, and it's not built to do that. So, and you'll feel if you keep it running long enough, the servo will actually get warm because it's trying very hard. So, if we leave it running like this for a long time, it might actually burn out the servo because we're working it too hard. So I recommend not going anywhere lower than 2 milliseconds. So I'll change this back to 15, what it was before, the normal speed. there we go. Back to normal. And this concludes our walkthrough of the example program. So now let's move on to figure out how to make both arms move so we can get RoboBear to hug. For this next part, we are done with the sweep example program, so we can X out. If it asks us if we want to save before closing, we can say no, don't save. What we can do now is on your desktop you should find a RoboBear folder. If you don't have one, don't worry. I will be posting links to where you can download the RoboBear folder, and you can go ahead and just copy and paste it onto your desktop so you have it here. So once you have the RoboBear folder on your desktop, go ahead and double click into it, and the folder should open up, and you should see RoboBear Hug folder and the RoboBear Walk folder. Let's go ahead and click into the RoboBear Hug folder, and then you'll see RoboBear Hug.ino. Let's double click the RoboBear Hug program, and it'll typically open a blank file, which we don't need, and then it'll actually have our RoboBear Hug program. So we can go ahead and maximize that so we can see it better. So we're going to step through this very quickly because we already went through the example program, and it's very similar to the example program. A lot of times in real computer engineering and in real programming, we take examples and sample files and sample code that already exists and we build on top of it. That's exactly what I did for RoboBear Hug. I took the sweep example program and I added on top of it to make both servos move and to move them the way I wanted to move them. So here at the top you'll see the same line, pound include servo.h, so that we can use all of the servo code stored in servo.h. Previously in the example file sweep, the servo was called my servo. Now we've called it left servo, and we have this second line, servo right servo. So now we've created a variable, a servo called left servo and a servo called right servo. And you guessed it, it's to represent, the left servo represents this left servo, the right servo we're going to use to control the right servo. Okay, and I'll draw out one more circle here, and I'll actually label this left servo, and I'll label this right servo. 0 degrees, 180 degrees. I'll keep the 90 degrees there, so it's a little easier to think about. Cool. So the first line says int left out equals 160. So what I'm going to do is I'm going to go here, write 160, label that left out. All right, can somebody read me the next line? Int left in equals 80. 80 is around here, 80 degrees. Left in. Now, because the servos mechanically are a little bit different, they're not, the angles on the servos are not exactly perfect, I'm actually going to redraw my circle a little bit, just to angle it out this way. So 90, I'm going to shift out this way. 0, I'm going to shift out over this way. And 180, I'm going to shift out a little bit this way. Just going to tilt it a little bit that way. So for the next line, we have int right out equals 30. So 30 is around here. And I'll label that right out. And the next line, the last line, int right in equals 80. So 80 is around over here. I'm going to label that right in. So essentially what these 4 lines are doing is it's setting how far out and how far in RoboBear's arms are going to move. So let's take a look at this piece by piece. So if we take the bear here and we just take a look at left, left out is going to be at 160 degrees out here. Left in is going to be in here. So out, in, out. Same thing with the right servo. Right out is going to be around here, 30 degrees. Right in is going to be around here, 80 degrees. So out, in, out, just like that. So together, the teddy bear moves like this, out to in to out, like that. In the setup, we have left servo dot attach 9, right servo dot attach 10. That makes sense? So this is because the left servo, this left servo yellow wire on the Arduino is attached to pin 9, and the right servo yellow wire is attached to pin 10. That's basically what it's saying. And then here we have left servo dot right left out, right servo dot right out. What we're doing here is in the setup gets run is the first thing that gets run once you plug in the battery. And it only runs once. So what this is saying is it's setting the initial position of the teddy bear to be out. So when you plug in the battery, the teddy bear's arms are going to be pointed out. Now, in this void loop section, it's just like the loop in the sweep example. The first for loop takes the teddy bear's arms from out to in, and in the second part, the teddy bear's arms go from in to out to in to out, and then repeat, loop, out to in to out, like this, forever. So let's go ahead and plug into Arduino and upload our program. So we have sweep here, and now both arms are moving. So in the RoboBear hug program, this is what the RoboBear hug program does. So let's unplug that. So let's take a look at the code line by line. Here, because we're moving two arms now, we can't just use 0 to 180 and 180 back to 0, because for example, as the left arm is going from out to in, from going from 160 to 80, the left arm is not also moving from 160 to 80, so they're not moving to the same angles. When the left arm is at 160, the right arm is at 30. And as the left arm is moving this way, clockwise, the right arm needs to move the other way, counterclockwise. So because of that, we can't just use one number, 0 to 180 or 180 back to 0, or 0 to 90 or 190 to 0. We can't use anything like that. So what I've done here is I'm going to represent out to in as a percentage from 0% done to 100% done. So in this motion from out to in, the starting position is out. So when we're out, we're at 0% done with the motion. When we are all the way in, we're done going from out to in. So we are at 100%. So here, what we're doing, let's take the first line, left servo dot right, and then we're using this map function. We're mapping numbers from 0 to 100 to our left out, left in. Don't worry too much if you don't fully understand this part. It's not too important, and it is a little bit complicated. Just know that this first section, the teddy bear's arms go from out to in, and in the second section, the teddy bear's arms go from in to out. Really, if you are trying to add on top of it, that's really all you need to know. So, but I'll kind of walk through this anyway. So we're mapping the 0 to 100% to our out to in motion, left out, left in number. Same thing with the right arm. We're mapping 0 to 100% to our right out, right in. So we can tell how our teddy bear is moving by reading it from left to right. So we're going from, let's just take a look at our left arm. We're going from left out to left in. And then here, at the same time, we're going from right out to right in, right out to right in. So, and these two lines get run at the same time, basically the same time. So we go from out to in. So reading from left to right, out to in. So that's how we find out that we're going from out to in this first for loop. And then we wait 8 milliseconds. And then in the second part, same thing, mapping 0 and 100% to the in and out. So here we can tell we're going from in to out, because on the left side here we have in, and on the right side here we have out. So we're going from in to out. So in this for loop, we are in our starting position when we're in. On our ending position is out. So at the start, we're 0% done going from in to out. When we're all the way out, we're 100% done going from in to out. So 0%, 100%, in, out. So, and that's basically how it works. And then of course, after we're done with this for loop, we go down here, and this just goes over and over again. So then we have this motion. So now, this part is this is the part we've all been waiting for. We understand how the program works. If you haven't already, go ahead and plug in the Arduino and press upload. Upload our RoboBear hug to the Arduino, and it should look like this. If your servos don't move like this, or if one of them is not moving, the first thing we can do if something is not moving right is taking a look at the wiring. Again, 5 volts goes to red, brown goes to ground, left yellow goes to 9, right yellow goes to 10. And now, for the moment you've all been waiting for, let's go ahead and put the robot parts inside the teddy bear. So first of all, let's go ahead and unplug the Arduino from the computer so it stops moving. Every time we do any rewiring, or we're trying to move the robot parts around, we want to make sure that they're not moving. Otherwise, we risk damaging some of the parts. One thing also is, while the servos are moving, we want to refrain from pushing them the other way. So say the servo is trying to move from out to in, we don't want to push it from in to out. Otherwise, the servo will still try to move it, and it might break some of the gears inside. And the other thing is, avoid running the servos for too long, because as we mentioned before, they do heat up. Does anyone know why the servos would heat up? The servos will heat up because of energy. The way energy works is energy goes from your battery. It starts off as chemical energy. It gets transferred to the Arduino as electrical energy. And the electrical energy goes into the servos and turn into mechanical energy to actually move the arms. However, the electrical energy doesn't all get converted to mechanical energy. So some energy is wasted, and that energy turns into thermal energy, or heat. So the electrical energy actually gets turned into mechanical energy to move the arms, and thermal energy, heat. So, what we're going to do now is we're going to go ahead and put the robot parts inside the teddy bear. This part is a little bit tricky, and if you're having a little bit of trouble, go and ask mom or dad to help out as well. So now we're going to take the robot parts and put them inside the teddy bear. So go ahead and bring the teddy bear on over. The way we're going to do is we're going to take, I'm going to take one hand, I'm going to take my left hand and hold the teddy bear with my left hand. I'm going to put my fingers and thumb around the teddy bear's left shoulder. I'm kind of pinch the left shoulder here a little bit like this. and we'll make sure that, that the hole is big enough to fit the robot parts in. If not, don't worry, you can always use some scissors and just kind of cut the hole open just a little bit more so it's easier to put the robot parts in. I'm going to take the robot parts in my right hand and my other hand, and I'm going to take the left arm. I'm going to hold the left arm here, the left robot arm, and then I'm going to pinch the left shoulder of the teddy bear, and I'm just going to put the arm inside the hole of the teddy bear, and I'm going to aim towards this way. So what we want to end up doing is position the servo here at the left shoulder of the teddy bear and have the arm go inside the left arm of the teddy bear. Let's go ahead and put this in, and I'm going to aim it to the left arm, and with my left fingers I'm going to pinch and try to feel for the arm. So I actually feel it now. It's going in here, so I'm just going to keep pushing it and keep pushing it until I feel the servo right here on the shoulder. So now the arm has gone all the way in to about here, and the servo is here at the left shoulder where it should be. So that's the left arm. Now a trick I like to use to make it a little bit easier is I like to bend the left arm in now. I like to fold the left arm in so the teddy bear is kind of hugging himself with the left arm, and then I'm going to put him on its back and kind of flip him around like this now. So now with my left hand again, I'm going to pinch the right shoulder here. I'm going to take my right hand and then angle the right robot arm down so I can get it inside the hole right here. And again, I'm going to try to aim it so it comes over here. So the servo's on the right servo's on the right shoulder, and the right arm's inside the teddy bear's right arm. So I'm going to go bend this in so it goes into the hole, and then I'm going to start poking it into the bear towards the arm. And here I kind of feel, oh, here's the arm. So try to guide the arm inside the teddy bear's arm. And at this point, I'm going to take here the teddy bear's skin, and I'm going to wrap it around the servo so I can get the servo all the way into the teddy bear. And with my left hand, I'm still going to try to feel for where that arm is, to try to move it around so it can just kind of slide into the arm a little bit easier so it doesn't get stuck. With my right hand, I'm going to keep pushing the servo in, and I want the right servo to get all the way to the right shoulder, right about here. So now both arms are in. I'm going to make one final adjustment. Take my hand and grab the this acrylic frame. I'm just going to hold that and move that around. Make sure that again the left servo is at the left shoulder. Take this to the right servo is on the right shoulder, and then I'm going to do a little test. So the arms move. If the arms are like stiff or they stop moving, go ahead and take the servos out. The servo might be broken, or something might be wrong. I can take it out and figure out what's going on. But do the test, and the arm seems to be moving properly. So now we have these wires coming out here. Before we move on, we can actually do a little test before we plug this guy in, just to make sure that the arms do move, because a lot of times we put the electronics here, the Arduino inside, and then one of the wires fall off, and then the bear stops moving. So let's go ahead and just test it out first. I'm going to go ahead and plug in the USB cable to the computer, and then I'm going to plug the power in so it starts moving. So this Arduino already has our hugging program, so we don't need to upload it again. So let's take a look, and there we go. So it is moving. So that's good. So I'm going to unplug it, unplug the Arduino. So remember, we saved this box from earlier. This is the original box that came with the Arduino Uno microcontroller. So what we're going to do is we're going to put the Arduino inside the box. Now that's for two reasons. One, it makes slipping in the Arduino inside the teddy bear easier. Second reason is it protects the wires from getting undone later, because that will happen. And having the box there definitely helps. So in order to get into the box, we need to make sure that the wires kind of lay flat so we can put the box over it. So right now it's a little lifted up right now. So all I'm going to do is I'm going to push down on it a little bit, so now it's a lot more flat than it was before, and make sure that this metal piece is not touching any other piece of metal, like over here or over here. And also just double check before we put it in, make sure all the wires are still attached correctly, and no wires have fallen out. So the right side looks good, and then the left side, make sure all the wires are still attached. Yep, that looks good. And the wires attached to the servos are all still plugged in. And yes, those look good as well. So now it's ready for the box. We're going to put it inside the box. And get this box, these flaps to open up a little bit. It's easier to put inside the box. I'm going to peel this off and put this inside. And there we have it. And we don't need to close the box because we actually need to power it later. So go ahead and put the teddy bear down, and we can put this box, slide this box inside. And what we want to do is we don't want to push it in like this into the bear. We want to get it inside the bear a little bit, and then we want to slide it down. We want to slide it down vertically, kind of towards the teddy bear's butt. So we slide it down like this, and this fits nice and snug there. And we have all the robot parts inside the teddy bear. For the last part, what we're going to do is we're going to power it. So far we've been powering it using the USB cable, the power from the laptop. So, but now we can actually power it from the battery now. So we can take our 9-volt battery holder, power plug, barrel jack adapter, and we can plug it into this hole over here on the Arduino. Plug this in, and just to make things a little simpler, I'm going to take this back out. You don't have to do this. This is just so you can see this a little bit easier. This actually goes in here, so you could probably plug this in first before you put it inside the box. So now that this is plugged in, we can put it inside the box. Put it back in. Okay, so now we can take our battery, 9-volt battery here, and plug it in. And there's actually two sides. There's a smaller hole and a bigger hole. So we want to make sure to match, and there's a smaller hole and a bigger hole here. We want to make sure to match the bigger hole to the smaller hole on the battery, and the smaller hole in the holder to the bigger hole on the battery. So put that in. Put that in. Sometimes it's a little bit hard to plug the battery in. Feel free to raise your hand, ask the teacher to help you push it in, or ask mom and dad to help you. Now observe how the teddy bear right now is not moving. And this can be for several reasons. It could be because some of the wiring got undone inside, in which case you can take it out and double check the wires, make sure they're all plugged in. But what I think the battery is out of battery. So what I'm going to do is I'm going to take this out. Remember the multimeter we had at the beginning of class? I'm going to take that out now. So this is the multimeter, and I'm going to use this to measure how much voltage is left in this 9-volt battery. This battery should have around 9 volts if it's brand new. What I'm going to do is I'm going to switch this to over here for measuring voltage, DCV, over to the number 20. And all that really means is how it displays the numbers to you. And I find moving it to here for measuring the 9-volt battery makes it easiest to see. So I'm going to change this to 20, and then I'm going to take the red and black parts here. Red goes to positive, black goes to negative. So I'm going to take the battery. Now the way I find out which side is positive and which side is negative is I look at the sides. Typically on the sides, somewhere around here, we'll find positive or negative. And here we see that this says positive. So I'm going to take red, goes to, I'm going to actually have to touch the metal. So the metal is the part that conducts the electricity. So I'm going to take the red and touch it towards the positive end, the black touch it towards the negative end, and we see that this is around 6.83 volts. Now, unfortunately, 6.83 volts is not enough voltage to power RoboBear. Typically, you want around 9 volts to 8 volts to power RoboBear. So we're going to get a new battery. So here is a brand new battery, and you'll notice at the top, the cap hasn't even come off yet, so we can remove the cap. You can throw this away afterwards because it's not going to reattach back on. So I'm going to take the multimeter again. So this is the new battery. I'm going to throw this old battery away now, so we don't get it mixed up later. So I'm going to take the multimeter. This is the plus side. I'm going to take red and attach it to the metal part of the battery, the positive part, and black goes to negative, and let's see, 9.59 volts. So I believe that this battery will have enough power to power RoboBear for sure. So one more thing with the multimeter, you don't have to worry too much about touching red to positive and black to negative. I'll show you exactly what happens when you flip them. So red is actually going to negative now, and black is going to positive. Now we see the same number, 9.59, but it's negative. Notice the minus sign here, negative 9.59. So that's because I switched. Red is going to negative right now, and black is going to positive. If I switch it back, red going to positive and black going to negative, 9.59, but then minus sign went away, so it's positive 9.59 volts. One more interesting thing we can do with the multimeter is we can actually measure the voltage of the battery with the barrel jack. So with the battery holder. So we can take this, attach it. And new batteries are a little bit hard to attach. You kind of have to press hard here. And so now it's securely attached. The way we measure the battery through the barrel jack is red goes on the inside. So positive is actually on the inside. So we just take this, poke it inside the hole here, and then black touches the outside. And now we have 9.59 volts. Same thing, because the electricity from the battery is being sent through the wires to the top here, so that we can measure it. So it's the same thing. So now for the last part, I need to put my barrel jack, attach it back into the Arduino inside here. Cool. And then I'll just sit RoboBear up like this. I'm going to take the 9-volt battery holder and the 9-volt, and I will attach it. And RoboBear moves now. Cool. So what I'm going to do with the battery is I'm going to push the wires inside the bear. I'm going to take the battery, push it down here, also inside the bear. Now, RoboBear actually doesn't close in the back. I find it easier to leave them open so that if anything goes wrong or if we need to replace the battery, we can just go in and take the parts in and out and exchange them. So right now, RoboBear just kind of stays open. Now, of course, you can always put a piece of tape or something over it so you don't see the hole, but here it is. This is RoboBear, and he hugs. And depending on how you want your RoboBear to look, you can now go back to your code and change the left out, left in, right out, right in numbers. So for me, I actually like how this motion looks inside the bear. So I'm actually not going to change these numbers here. But if you wanted to, say, if you wanted to make the left arm here go out more, all you have to do is make this number bigger, closer to 180. Likewise, if you want to make the left arm go in more, you can make this, instead of 80, you can make this something smaller, like 70, 60, something like that. Now, for both the left arm and the right arm, I recommend not making RoboBear's arms go too far in. The reason is, and for this part, I'll unplug the battery for now. Unplug. Yep. Take the battery out. So whenever we're moving the parts around, we want to make sure we unplug the battery. So the reason we don't want to move the arms in the program too far in is because everybody kind of do this experiment. So take the teddy bear, the servo should be inside, and just kind of push the arms in a little bit gently, and then let go. Push them in a little bit and let go. You'll notice how naturally RoboBear wants to move his arms back out. Meaning when you push the arms in, that's an unnatural position. There's resistance from the bear's arms, and it wants to go back out. Meaning there's force pushing the arms back out this way. Meaning when we are sending electricity through the servos, if we make RoboBear's arms move too far in, the teddy bear's arms are going to push back out the other way. So remember when I said earlier that it's not a good idea to push against RoboBear's arms when the servos are trying to move a certain way. The same thing applies here. So it'll take more power, more battery power, to make RoboBear go in farther than if we just left him moving kind of in this comfortable position. Now you'll find that you might find that a couple problems that you might see is if you see RoboBear kind of hug a little bit and then like jump back, and then try to hug a little bit and jump back. That might be an indication that the arms are trying to go too far in, and RoboBear is having trouble push all the way in, and we're actually pushing. What ends up happening is if we push the arms the other way when they're trying to go in, we're actually pushing electricity back into the Arduino. And when the Arduino gets electricity back, that's not supposed to happen. Arduino will, as a safety measure, it'll reset. So that's why you might see it try to go in and then reset, and then try to go in because the teddy bear's arms are pushing back. Electricity is getting pushed back to the Arduino. The Arduino, as a safety precaution, resets back to this initial starting position. A couple things that you might see happen if you swap the wires, pin 9 and 10 wires, you'll see RoboBear hug really far in and then kind of come out here and really far in. If you see that one arm moves but the other one doesn't, very likely one of the wires for the left arm fell off, whether it's the 5V or the brown or the 9, or if the right arm stopped moving, the 10. And also if RoboBear is just not moving at all, you might want to double check the voltage on the battery. If it's less than 8 and RoboBear is not moving, then it probably means it doesn't have enough power. Unfortunately, RoboBear does require a lot of power to move, and 8 volts to 9 volts is the best ideal range for that. So now that we have the hugging done, if you want to do the walking, we actually just use the same parts but with the walking frame. Let's go ahead and take a look at how we can do that. So if you do want to do the walking, what we can do now is we're going to be taking the robot parts out, and we're going to be doing some rewiring so that it can do the walking. Now if you don't want to do the walking and you want to just keep the hugging, you can just keep the hugging RoboBear as it is right now. But if you want to do the walking, you can follow these instructions here. So what we're going to do is we're going to take the Arduino back out of RoboBear, and then the way you take the arms out, very similar to how you put them in, except I'm grabbing onto the acrylic frame, and then with the other hand I'm grabbing the side here, and I'm just going to get the servo to come out this way, and then I'm just going to slide the left arm out. And once the left arm comes out, I can just kind of slide the right arm back out, and some fluff will come out. We can just put that fluff back inside the bear here. And then once the parts are out, we can set the teddy bear aside for now, and we can go ahead and take the Arduino back outside the box. And now time for the rewiring. We're going to do the rewiring to get the RoboBear walking to work. So the first thing we're going to do is we don't have to unplug all of the wires. So this is important. We don't have to unplug all the wires. We can keep all the wires the same, connected to the Arduino. but instead, all we're going to do is we're going to unplug the wires that are attached to the servo. And the way I like to do it is I just like to unplug them one at a time, just so it's a little simpler. So I'm going to take the left servo wires and I'm just going to unplug these. So I'll unplug these now. And now I'm going to take the left servo out of the hugging frame. And now I'm going to take the left servo and put it inside the walking frame. And the way we put it inside the walking frame is, remember before we took the wires and plugged them through the holes. Well, we're not going to do that this time. So we're not going to do that. Instead, what we're going to do is, notice how we have this hole here. I'm just going to slip the servo in like this. Like this. And then it should fit on pretty tightly as it is right now. So this is pretty tight right now. If it's not tight enough, you can always wrap some tape around here. I find that the tape always helps. Then I'm going to take my wires and I'm going to plug them right back in here. So 5 volts goes to red, brown goes to ground, and yellow goes to 9, because this is the left leg. So brown is over here, brown goes to ground. This is, oops, I had that mixed up. This is the 5 volts, goes to the middle one, goes to red. And then the 9 goes to the yellow of the left servo. So this is the left leg here. And now I'm going to swap out the right. Oops, this wire just fell off. And this will happen if you notice that a wire does fall off. Go ahead and plug it back in. So now I'm going to rewire the right servo. So I'm going to take the right servo wires, unplug them from the hugging frame. I'm going to take my right servo out of the hugging frame. And now I'm ready to put the hugging frame aside. So I'm going to take the right servo and then we'll do the same thing. Now this is very important. We want to make sure we put the servos in facing the same way, and we want to do this because it makes the programming a lot easier later. So not like this, but like this. So both the top of the servo are both pointing left over here. So I'm going to plug this guy in, and slip it in here like this. So now that we have the servo, the right servo attached to the walking frame, we're going to go ahead and take the wires for the right servo and attach them to the wires on the Arduino. So again, same thing, brown goes to ground, and then the 5 volts goes to red, and then the 10 goes to the yellow, and this is the right leg. And just like that. So at the end, you should see something like this. And go ahead and double check your wiring. Once that's done, you can go ahead and put it inside the bear. So once again, we'll go ahead and take our teddy bear, put it down, and with my right hand, I'm going to grab the left servo here. So the way to tell front and back, because there's no, the wires are facing down, they're not facing one way, facing the front. We want to hold it with the side, with the top of the servo is facing left. So this way is back, that way is front. So this is the left leg, and this is the right leg. So I'm just going to take the left leg with one hand, with my right hand, and then with my left hand, I'm going to go ahead and pinch the left leg, and I'm going to take the left robot leg and poke it in down towards here. So at the end of the day, what I really want is I want the legs to be down around here. So the servos, again, at the joint of the leg, and then the robot legs inside the teddy bear's legs. So go ahead and put that in and aim it down towards the legs, and with my finger I'm pinching and feeling for the legs. So I feel the leg here now. So I'm going to keep pushing that in, and now once I have it in quite a ways, I'm going to, here's a trick to make it a little bit easier. I'm just going to rotate this servo into the bear like this. So now the servo is inside the bear, and you'll notice the teddy bear kind of does this little cross leg over here, and that helps put the right leg inside the teddy bear. So now we can just take this side and then the leg, put the leg inside the bear. So now that the bear's, now that the leg is inside the bear, I'm going to take my right hand on the right servo, and I'm just going to push the leg down to the teddy bear's right leg, and all while pinching and feeling. So now it feels like it's going in, and I'm going to push it down as much as I can. And once I have both legs down in there, the one final thing we have to do is, again, take your fingers and grab the walking frame and just kind of push, make sure both servos are as far down as we can push it. And we can actually remove or move some of the fluff if that makes it easier. So just kind of move the legs around here. Make sure the more center the legs are in the middle of the teddy bear's legs, the better. But if they're off to the side a little bit, the left or the right, that's okay. And just make sure that the servos are as far down towards the butt as possible. So push this down. So the farther the servos are, the lower the servos are to the legs, the more the legs will be able to walk. So the servos are in there now. Before we put the Arduino inside, we want to make sure we test we test our program to make sure that it does move. So we can go ahead and go to our computer now. Now we're back on our computer. We can go ahead and X out of RoboBear Hug. And if it asks us if we want to save, we can go ahead and just say don't save, unless you did make some changes and you want to save it. And once we get back to the desktop, we can go back into our RoboBear folder, open up RoboBear Walk, and then open RoboBear Walk.ino. So now we have our RoboBear Walk. Go ahead and maximize it. In the RoboBear Walk program, we have essentially the exact same code as the Hug. We still have the left and right servo, but instead of out and in, we have forward and back, because the legs are moving from forward to back and back to forward. So we have our forward set to 60 degrees and back set to 120 degrees. And then we have our back set to 120 degrees. So now let's take a look at our setup. In the setup, we have the exact same thing. Left servo is still 9, right servo is still 10, and our starting position is going to be left forward and right back. So our starting position is going to look like this. The left leg is going to be forward, the right leg is going to be back. So the RoboBear is going to start looking a little like that. So, and in the loop, we have the same thing, the 0% to 100%, and we map 0 to 100. We're going to go start off with left forward, and then right back. And then in the first part of the for loop, we're going to go from here to here. And then in between each step, we're going to delay 3 milliseconds. So we have them walk a little bit faster than it hugs. And then in the second part, left back is going to go, left is going to go from back to forward, right is going to go from forward to back. So basically what happened was, in the first for loop, we go from, we do this. In the second for loop, we do this. First for loop, and then we loop back to the top of the loop, and we do this again. We do this in the first for loop, and then do this, and then this, and then this, and this, and then this, and that's how you get the little walking motion here. So let's go ahead and upload that now. We'll take our Arduino, and we will plug it into the computer. And if you still this is what the this is still the hugging program, so look a little bit strange. Let's go ahead and just upload the walk program now and test that it works. So that's what it looks like. So let's go ahead and unplug it from the computer. The main reason for that test is to test that both legs move. If both of your legs are not moving, then it might be because the wiring is off, and you can, since your Arduino is still here, you can double check the wiring. Again, brown goes to ground, 5 volts goes to red, left leg goes to 9, right leg goes, left yellow goes to 9, right yellow goes to 10. Once you see both legs moving, when you plug it into the computer, then we can go ahead and do what we did before. Take the wires, bend them down a little bit so they're flat. Take the box, put the Arduino inside the box, like this, and then with a teddy bear, put the box inside the bear, like that. And then we can go ahead and take our battery, and again we want to match the small hole to the big hole here, and the big hole to the small hole here. And he's walking. And go ahead and plug the battery inside the bear, get the wire inside, and there you have it. It's the walking RoboBear. And the cool thing about the walking RoboBear is he can kind of walk. He can't stand on his own, but if you tilt him like this way a little bit, and then just with your hand hold his butt here so he doesn't fall, and then just kind of let him move, you could kind of feel him walking. And there you have it. And this is the walking RoboBear. So again, with the walking RoboBear, you can customize the code to make him move its legs farther or less far, make him move a smaller walk, bigger walk, faster walk, slower walk. You can also play around with code and make him say like do a right kick or something and move back, or a left kick or something like that. So I encourage you to play around with the code. There's a lot of really creative things you can do with it. Oh, and one last thing. If you're not really doing anything with RoboBear, I recommend unplugging the battery from the back so that we can save the battery power and we can continue to use it later. If we do run out of battery, that's okay. You can pretty much get these 9-volt batteries anywhere at like Walmart or Amazon. Or congratulations on building your RoboBear. Building your RoboBear is a very big accomplishment, and if you're your RoboBear kit should come with one of these RoboBear badges, and this is proof that you guys learned how to build your RoboBear from the scratch, putting all the circuits together and learning how to do all the programming, so that you know how to build. You can build another RoboBear if you needed to, or if RoboBear stops working, you can take him apart and figure out what's wrong and fix RoboBear. I learned how to build RoboBear very late in my senior year of college, actually, when I was 22, and you guys did it in elementary school in a couple of hours. So kudos to you guys. You guys are awesome, and this is proof, the RoboBear Engineer badge. So from this day forward, you guys are official RoboBear engineers. So thank you for taking the RoboBear workshop. I hope you all enjoyed it. Bye!